There are two basic factors to keep in mind when choosing an amp that is compatible with your speakers: impedance and power. And as you'll see, these two factors are very closely interrelated. Impedance is measured in ohms and refers to the opposition a circuit presents to electric current. The first step in choosing an amplifier is to determine the nominal impedance of your speaker or speakers. You can find the nominal impedance of your speaker in the technical specifications on the manufacturer's website, and the nominal impedance of a speaker is most often 4, 8, or 16 ohms. If you're connecting multiple speakers to a single amplifier channel, finding the total impedance can be a bit more complicated. So check out the post I made on calculating speaker impedance using the link below the video. Power is measured in watts and refers to the rate that energy is transferred. The power handling rating of your speaker can also be found in the technical specifications. You'll probably find various power ratings in your speaker's technical specs: peak power, continuous power, etc. Peak power refers to the maximum power a speaker can handle without damage, and this specification can often be misleading. We're more concerned with how much power the speaker can handle over an extended period of time. This is the continuous power rating of the speaker. Depending on the manufacturer, RMS or AES specifications might be given instead of a continuous power rating, but be sure to note how the power rating was measured if you can, as this will tell you if the rating was measured using a particular test tone frequency, like 1 kilohertz, using pink noise, or using music. Now that you know the nominal impedance and continuous power handling capacity of your speaker, it's time to choose an amplifier. Let's say I'm trying to find an amplifier to power 2 QSC E115 speakers, and we'll assume that we'll only have one E115 speaker on each amplifier channel. I'll make sure that the amplifier is rated to operate at the speaker's nominal impedance, which is 8 ohms. If the impedance of the speaker is lower than the amplifier is rated for, it will probably cause the amplifier to overheat. But if the impedance of the speaker is greater than the amplifier is rated for, the sound quality and performance of the system will be negatively affected. The next step is to make sure the amplifier is capable of supplying enough power to the speaker. The continuous power rating of the E115 is 500 watts, but like I said, impedance and power are interrelated. You can see this by looking at amplifier specifications, such as those for the QSC GXD amps. At 4 ohms, this amplifier is capable of supplying 800 watts of continuous power. However, at 8 ohms, the amplifier is capable of supplying only 400 watts. Choosing an amp that supplies too much power makes it possible to exceed the limits of the speaker. This is true. Of course, when the speaker begins to distort, you'd hopefully hear that distortion and turn it down to avoid damage.